Welcome to Probability and Statistics in Python. In this hands-on lesson, we will discover conditional probability and independence. You will learn key ideas, see examples, and try simple code. No prior experience needed. Let us start by understanding basic probability, then build toward real-world analysis. Running the cell now. Let us get started. What is probability? Probability is the chance that something will happen. For example, if you flip a coin, the chance of getting heads is 0.5 or 50%. Probabilities are always between 0 and 1. Running the cell now. Let us set up our tools. First, we will import libraries for working with probability and data. Suppressing all warnings will make outputs cleaner. NumPy helps us make random events and math easy. Pandas lets us handle and explore data. Running the cell now. Let us continue with some basic experiments. Let us flip a coin in code. Now let us simulate flipping a coin 10 times. We use random choice to pick heads or tails for each flip. We print the result so you can see the outcomes. Running the cell now. Try changing the number of flips to see what happens. Let us see how many times each outcome happened. We count how many times we got heads and how many times we got tails. Unique finds the different results, counts gives how often each appears. We put this into a dictionary for easy reading. We print these counts. Running the cell now. Notice that sometimes heads and tails are not exactly even. Probability does not guarantee results in small samples. Let us find the probability of heads from our experiment. We find the estimated probability for heads by dividing the number of heads by total flips. If there are no heads, the answer will be 0. We print our calculated probability. Running the cell now. Try running several times and watch how the probability changes. Conditional probability, what does it mean? Conditional probability answers, what is the chance of event A, given that event B happened? For example, what is the chance a randomly chosen Titanic passenger survived, if they were female? It is written P, A, B. Running the cell now. Let us use a real dataset to see conditional probability in action. We will use the Titanic passenger dataset, which has survival information. Seaborn lets us load this data easily. Shape tells us how many rows and columns are in the data. We look at the first few rows for a preview. Running the cell now. Look for columns like sex and survived, these will be useful for analysis. Let us find the chance that any Titanic passenger survived. We calculate the overall probability that a passenger survived. Then survived column is 1 for survived, 0 for not survived, so mean gives the fraction survived. We print this probability. Running the cell now. This shows how common survival was, without looking at any conditions. Now let us look for the probability a passenger survived, given they were female. We select only rows where the passenger is female. Then we find the average of a survived for these rows. This gives us the probability that a woman survived on the Titanic. We print the conditional probability. Running the cell now. Notice that this probability may be higher than the overall chance. Let us check the probability for men as well. We filter the data to only male passengers. Then we calculate the survival rate for males. This shows the probability a man survived. We print the result for comparison. Running the cell now. Try comparing this to the female probability. What do you notice? Let us see how survival chances change by ticket class. Now, we will check each passenger class by looping through classes 1, 2, and 3. We group passengers by class. Then we find the survival probability for each class. We print each probability to compare. Running the cell now. Class can really affect survival rate. Look for patterns. What is independence? Two events are independent if knowing that one happens does not change the chance of the other. If events are not independent, their probabilities change when you know something. Example, flipping a fair coin twice, the result of the first flip does not affect the second. But, on the Titanic, survival and being female are not independent. Running the cell now. Let us see if survival and being female are independent on the Titanic. We check independence by comparing probabilities. We remind ourselves of the overall survival probability and the survival probability for women. If these match, the events are independent. We will print our calculated probabilities. We check if they are close using the isClose function. If they match, we say the events are independent. Otherwise, we say the events are not independent. Running the cell now. Most real-life features are dependent, knowing one thing changes possibilities for another. Charts can help reveal relationships, too. Now we make a bar chart to compare males and females by outcome. Crawstab sums the number of survivors and non-survivors for each sex. We plot the result as stacked bars for an easy visual comparison. We label axes for clarity. We give the chart a title. The legend shows which group is which. We show the chart to see the difference. Running the cell now. Notice how much clearer the differences are in a chart. Let us make it personal using conditional probability. Now you can enter your name and gender. We will use the actual survival rates to predict your chance if you were on the Titanic. Your result uses the conditional probability for females or for males. We print a personalized message with your survival chance. Running the cell now. Practice prompt, change your input and observe your result. Let us see independence for dice. We roll 2 dice 1,000 times each. We make event A, the first die is 6. Event B, the second die is 6. We find the probability of each event. Then we find the chance both are 6 at once. We print probabilities for event A and event B. We also print the probability both happen together. If dice are independent, the chance of both is the product of their individual chances. We print out the check value, too. Running the cell now. Try changing the number of rolls to see if results change. Quick recap. Probability measures how likely events are. Conditional probability asks about chances with context. Independence means one event does not affect another. Real datasets can help you see these ideas clearly. Running the cell now. What else would you like to practice? Try the challenge exercises below. Let us test your understanding with a challenge. This challenge asks, what is the chance a third-class female survived? We filter both for third class and female. Then we find the average survival value for this group. We print out the answer for you to compare with earlier results. Running the cell now. Try changing filters, like class or sex, for more practice. Let us see if sex and class are independent. We calculate the overall chance of being third class and chance of being female. If independent, the chance of both is just the product of the two. We also find the observed chance of being both at once. We print both the expected and actual values. Running the cell now. You can see if class and sex are actually independent or not. Next steps and tips. Always define what your events mean. Use real data to test how events relate. If you are not sure about independence, calculate and compare like we did. Try sharing this lesson or leave a comment about what you discovered. Running the cell now. If you enjoyed, please like and subscribe for more hands-on lessons. You finished. Rock it. Review. Try describing conditional probability to someone else. Change code and rerun experiments. Come up with your own real-world example and test it in Python. Thanks for learning with us. Running the cell now. Share your favorite insight in the comments and subscribe for more YouTube shorts and in-depth lessons.